Today we're going to go over dividing rational expressions. And in our second warm-up here, we're reminded that to divide normal fractions, we typically use the method keep, change, flip. So what that means is that we keep the first fraction as is. We don't do anything to it. We change the division into a multiplication, and then we flip the second fraction into its reciprocal. When we do keep, change, flip, then we've changed division into multiplication, and that is an operation we're much more familiar with when it comes to operations with fractions. And that's the same process that we're going to use here for dividing rational expressions. So we see the steps on the left. Again, keep, change, flip is what we want to do. Keep the first fraction, change the sign, and flip the second fraction. After you do keep, change, flip, then you should factor both rational expressions, both the first and the second. After you do that, you're going to find the excluded values. But here's something new. All factors in the second fraction are considered excluded values, since technically we're dividing by that fraction. So what do I mean? If you look at example 1, I have m squared over m plus 5. We know that we're dividing m squared by m plus 5, right? And we cannot divide by 0. But then we're taking that fraction and we're dividing it by this fraction. So that means this fraction, the entire fraction, cannot be 0. Otherwise, I'm dividing by 0, and that's not good. So that's why our excluded values come from both the denominator of the first fraction and the numerator and denominator of the second fraction. Finally, the last step is to multiply straight across and then cancel as we did in simplifying rational expressions and when we did our multiplying notes as well. So we're going to get started here with the first problem. First step is to keep the first fraction the same. So m squared over m plus 5. Next, we're going to change the sign from division to multiplication. And finally, flip the second fraction into its reciprocal. So m squared plus 10m plus 25 is in the numerator over m squared plus 5m in the denominator. There's our step 1. Step 2 is to factor. In the first fraction, m squared does not factor. M plus 5 does not factor. In the second one, m squared plus 10m plus 25, that should factor. So I'm looking for two numbers that multiply to 25 but add to 10. That would be 5 and 5. So this one factors to m plus 5 times m plus 5. Now in the denominator, m squared plus 5m, I can factor that one as well. It is not big X because it does not have 3 terms. It is not perfect squares because 5 and m are not perfect squares. But what we can factor out is a GCF because both m squared and 5m have an m. So we're going to factor out a GCF of m, and we're left with m plus 5 in parentheses. I can rewrite this just so it's a little bit neater. We've got m squared over m plus 5 times m plus 5 times m plus 5 over m times m plus 5. Next up, I'm going to find the excluded values. Remember, they come from the denominator of the first fraction, so that's right here. We say m plus 5 cannot equal 0. So we know m cannot equal negative 5. And then they also come from everywhere in the second fraction. So that'd be m plus 5 here, the m plus 5 here, m plus 5 here, and m. So remember, any variable is an excluded value potentially because that's the unknown. We don't know what's going to be plugged in for m. Now the 3m plus 5s, we already set m plus 5 equal to 0. You don't have to do it again. You'll get the same answer. It's not necessary. But the last one, m, set equal to 0, and that there's nothing to solve. We just know that m cannot equal 0 because we plug in 0 for m, it will make that denominator 0. All right, now that we have our excluded values, we're ready to multiply straight across. So when we multiply straight across, remember, you can just make this one big fat fraction. If you need to add some parentheses, you always can. And then we're going to simplify whatever common factors we see. So I see an m plus 5 pair. That's one. I see another m plus 5 pair. So those also cancel because they're in a pair. And then I see m squared over m. I know that those can simplify. They both have m. If it helps you to rewrite it, you certainly can. M squared over m. Well, what would m squared divided by m be? That would be just m. So there's our simplified expression, and we have our two excluded values. All right, let's try another one here. Number 2. Whoa, that looks a little bit crazy, but don't be too overwhelmed. We have our first fraction here divided by our second fraction. It's still just division. Even though it looks different, it's the same thing that we just did. If it helps you, of course, you can rewrite this. So it's x squared minus 4x over x squared minus 8x plus 16, then divided by 12 over 2x minus 8. Now we can go ahead and factor. In the top left numerator, x squared minus 4x, I can factor out a GCF of x. So I'm x times x minus 4. In the denominator, x squared minus 8x plus 16, we're looking for two numbers that multiply to 16 but add to negative 8. That would be x minus 4 times x minus 4. And then in the second fraction, 12 does not factor, but 2x minus 8, I can factor out a GCF of 2. So I've got 2 times x minus 4. All right, now before we're ready to multiply, we need to do keep, change, flip. I think I did this a little bit out of order of what the steps say, but at this point, it's okay to do it one way versus the other, as long as you are finding the excluded values before you cancel. So I'm going to go ahead and do keep, change, flip now with my factored form. We're going to keep the first fraction, which is x times x minus 4, over x minus 4 times x minus 4. We're going to change division to multiplication, and we're going to flip the second fraction to be 2 times x minus 4 over 12. Now when I look for excluded values, I'm going to look in the numerator of the first fraction, and then both the denominator of the first fraction, and then both the numerator and denominator of the second fraction. So we've got the x minus 4 in the numerator of the second fraction. The denominator just has 12 with no x's. So there's no way that a variable would make that 0, so there's no excluded value in that denominator. Now I notice that all of these factors are all the same. It's all x minus 4 cannot equal 0. We solve that and we get x cannot equal 4. So that's pretty easy. We've got the same excluded value for all of them. And now we're going to multiply straight across. We can make this one big fraction and start to simplify any factors in common. So I notice an x minus 4 pair. Those cancel. I notice another x minus 4 pair. Those also cancel. I'm left with x and 2 in the numerator and then 12 in the denominator. Now, another thing I noticed, though, is that we have 2 over 12, and 2 and 12 share a GCF. They're both divisible by 2. So I can actually simplify that by dividing 2 by 2, which is 1, and dividing 12 by 2, which is 6. So really, I have x times 1 in the numerator, so x, over just 6 in the denominator. And there's our simplified fraction.